In previous videos, we discussed two main types of formulas. Horizontal formulas, of which we presented a couple of examples, and aggregate formulas, such as those used to sum or count records. This video will focus on the latter. If from anywhere we wanted to count all the records in the flight seats table to determine the total number of seats for all the existing flights in our database, let's assume this is the current data in the table. We use the count formula. Here, we're telling it to count the occurrences of the attribute flight seat location, which, as we know, is a secondary attribute of the flight seat table. Telling it to count the occurrences of that attribute is the same as telling it to count the records in the table. Notice that we are not explicitly telling it which table to navigate to count its records. It infers that from the attribute we specify in the formula. Now, we wanted to count the occurrences of that attribute only if it's flighted tau 1. We add the condition as the second parameter. This way, we are telling it to count only the occurrences of flight seat location that correspond to flight ID 1. In this case, it will count these 4. These other 2 will not be included in the count. Here, in the filter condition, we are using an attribute from the same table on which the aggregation is performed. Note that we could apply a filter by the same attribute that is being counted. We would write the condition like this if we wanted to know the number of seats on all flights that correspond to window seats. Only these 2 will meet the filter criteria and be counted. The rest will not. What if we wanted to count the window seats but only of flight 1? We write the compound condition using the logical operator AND. Both conditions must be met. In this example, only this record will be counted, because it's the only one that meets both conditions. The rest do not meet at least one. Of course, filters can be set on the extended table. For example, we want to count seats of flights whose price is greater than $1,000. Note that flight price is an attribute of the extended table. All occurrences of this attribute, flight seat location, will be counted in its table, provided that its associated record in flight has a value in this flight price attribute that is greater than 1,000. So these 3 will be counted. These 2 will not. And this last one will. So with this data, this formula will return 4. One last example. Count the seats of all flights arriving at the airport named Guarulhos. Remember that we had the airport table, referenced from flight through this subtype attribute of airport ID. It is through this group that flight arrival airport name corresponds to its airport name. This way, only the flight seat records corresponding to a flight whose flight arrival airport ID matches the airport name Guarulhos will be counted. So far, we've only seen in abstract terms that the KB uses the count formula to count occurrences of an attribute in a table, with the option to set filters to determine which records to include in the calculation and which to exclude. Now, let's look at it more concretely by defining for the flight transaction a flight capacity attribute that will be calculated using this formula. Before doing this in GeneXus, note that since the formula attribute is just another attribute of a flight, just like the flight has a departure airport or a price, it will also have a capacity. That is, a specific number of seats. Whenever that value is needed, the value of the flight capacity attribute, the formula calculation will be triggered. However, since this is no longer an abstract case but rather associated with a specific flight ID, meaning it's as if there's an in-memory variable with that flight's value, indicated by the @ symbol, which represents an internal implicit variable that won't be visible in the object, there will be an implicit filter on the records to be counted. Not all the flight seat records will be counted, but only those that correspond to the given flight ID. Let's go to the flight transaction to define this new attribute in the flight capacity structure. we'll leave the default data type numeric of 4. And in the formula column, we type count flight seat location. We save, and the formula icon appears to the left of the name. If we go to the source, we can see how this was expressed. Let's test it. F5. If we access Flight 1, there we can see the formula attribute, which is read only as expected, and with the value 6, which corresponds exactly to the 6 seats in the flight. Let's see what happens if we add a new seat. For example, row 2, A, window. Before leaving the last field, the capacity still says 6, but as soon as we exit the field, it updates and shows 7. However, we haven't confirmed yet, so this row hasn't been saved to the table. The formula performs the calculation in memory to provide immediate feedback to the user. But if we don't make the change and edit Flight 1 again, we can see that when it's loaded from the database, it still shows the 6 seats that were actually saved and the value 6 in the formula attribute. If we add the row again and this time confirm, after exiting and re-entering, we now see 7. If we now only wanted the formula to count the number of window seats, with this data it should return 3. Let's manually edit the formula to add what we call a filter condition. We add a comma, and as a second parameter, flight seat location equals the name of the domain, seat location, period. We see how the names of the 3 possible values of the enumerated domain appear. Window. We confirm. This is how it looks in the source. Let's run it. F5. Flight 1, as we expected, shows the value 3, which is the number of window seats we entered. Here we see the formula as we have it so far. What would happen if there were no records that met the condition? That is, either there are no entries yet for the flight, or the entries do not correspond to a window. What result will count return when it finds no records to count? By default, it will return 0. If we wanted to return something else in the event that there are no records, the formula includes a third parameter, which is precisely to indicate the value in that case. We can even specify 0 if that makes us feel more comfortable. Let's go back to GNexus and leave the formula without conditions. That is, calculating all the seats on the flight. Aggregate formulas are so called because their calculation is performed by running through multiple records of the same table. Here we saw the count formula, but there are other types. Sum, to add up the value of an attribute, optionally applying conditions. Average, to calculate the average. Max, to select the record with the highest value for the specified attribute from a set of attributes. Min, to do the same but with the minimum value. And find, to find a record among many. You can find detailed information about each of these formulas in our wiki. In summary, we saw 2 types of formulas. Horizontal formulas, such as the attribute flight final price, which was defined as a calculation based on the record being processed, accessing, if needed, related records through the extended table, such as airline discount percentage, which is inferred from the airline entity. We also saw that a formula attribute can be defined with one calculation if a given condition is met, and another calculation if that first one was not met or if another one applied. Then we saw aggregate formulas, such as that of the flight capacity attribute, which requires navigating many records from the same table to perform its calculation, in this case, from the sublevel of the transaction. The current record being processed when the formula is triggered will, if applicable, act as an implicit filter, as in this case. It will not count all records from the navigated table, flight seat, but only those corresponding to the current flight day. There is a second parameter that's hidden. We saw that in these formulas, the second parameter is the filter condition to determine whether or not a record should be considered for the calculation. We also saw that we can specify a third parameter, which will be the resulting value if no records are found to be counted. Just like for the attribute we saw as a horizontal formula, we can, for the aggregate ones, perform different calculations based on trigger conditions. For example, we may want the flight capacity to match exactly the number of flight seat records for the flight, if its price is less than 5,000. But otherwise, we want 10% of the flight seats to remain empty. So we apply this other formula in that case. A formula attribute can be calculated as horizontal under one condition and as aggregate under another without any issue. We will not cover all the possibilities available for more complex formulas here.